Hi, I'm Dr. Mamari again, and I'm going to perform the second experiment for you, which is the qualitative analysis of group 1 and 2 unknown solution. So for the unknown, I hope at this point you have a good idea about the observation for presence of any of the ions or cations from group 1 and 2 for silver, for lead, for bismuth, and copper. If you have those evidences while I am performing the experiment, then you can say you have it or you do not have it. Just not to ruin it, I'm not going to tell you what you have or look, this is the evidence for what you have, because then I don't know what you would do. So I'm just going to show you, here is the evidence. I follow this step, and here's the evidence. Then you are going to based on the reference book that you have from your lab notebook and the evidences and observation you have for part 1, the last experiments that you saw for the known samples, you come to a conclusion which ions are present and which ions are not present. I try not to give away the answers. Let's see. I'm going to again show you the flow chart, and for you that would be a good place to start, because for when you look at the procedure you say, well, there's nothing in the procedure, I don't know where to start. Well, the unknown is going to follow the same procedure as the known, with exceptions that some of them would be positives, others would be negative. So if you have your observation properly recorded, then you are going to see that if when you add HCl, let's say you may not have any precipitate. So if you don't have any precipitate, what is the situation? Do you have silver or lead? Probably not. But if you do have precipitate, you have at least one of them, or maybe both of them, and then you are going to continue the procedure. So without wasting time, I'm going to start with the unknown procedure for your unknown sample. I'm going to take one unknown and I work with it. We have like plenty of unknowns. I usually have students pick up randomly and just pick a letter, and then I give them the unknown, or pick a number, then I have associated letters to give it to them. But right now I'm just going to pick one and start working with that one unknown. So watch me and identify your unknown. I am going to take these are known solutions, unknown. Again, we are working with strong acids. Use of gloves. I don't always use gloves in the lab, which is not good. I should. But if I know my chemicals, I already look at the risk and the hazardous sheet, the data sheet, the MSDS sheet for them, then I can live without it. But there are some of the experiments that they require strong acid, strong base, or corrosive compounds. I definitely have to use it. Okay, let's take an unknown from group 1 and 2. These are unknown. Okay, this is 1 and 2. Just going to take an unknown, following the same procedure as before, adding 10 drops of the unknown mixture. Start with the 10 drop of unknown, and with the 10 drop of unknown, the next step would be to add drops of HCl. So I'm going to add HCl. First, 4 drops of HCl. 1, 2, 3, 4, 5. Okay. I have the next step. So When I added HCl, this is how it looks like. Okay, this is how it looked like after I add the HCl. So you can record your observation. Too much water in the counter test tube, so I'm going to get some of it out. Make sure it's the same level. This is just to balance the centrifuge. So it has to be mixed well. Then when it's mixed well, going to centrifuge it. The procedure is just like known. Okay, I'm just following the procedure and showing you how it looks like. So I'm on step 1A2, but this is for unknown. Okay. 1A2 is asking me to add 2 drops extra of the HCl. If new precipitate forms, centrifuge, no new precipitate for me formed. So I'm going to decant and save for next. It wants me to wash it. Washing, just add water, mix it well, centrifuge. That is just to wash the precipitate. Okay. So wait until it stops. Good. This is just to wash the precipitate. I don't need the liquid. Centrifuge one more time because I dropped the precipitate. Okay, we are still on step 1, 2. So I had to repeat. Wait until it stops. To wash the precipitate. Sure, it's the same. Same level. You're still in part. I'm in part 1A4. So I'm washing the precipitate, just to let you know. I already have the clear solution that I'm saving for later. 1A4, waiting for centrifuge to stop. Okay, that's the wash. I'm going to, I don't need the liquid. Part B, 1B. For part 1B, adding distilled water. This is hot distilled water. And place in hot water bath. So mix it well. Place in hot water bath for a minute. That is the part 1B1. I added the water and place in there. Next, I need to decant it while it's hot. Centrifuge it was hot and then decant. Wait for centrifuge. Okay. And this is part 1B2, which I'm going to decant into clean test tube. Decant into clean test tube. Liquid is used in part 1C. Liquid will be used in part C. The solid would stay for later. Just want to get the liquid out. Okay. Saving the solid. This is the liquid portion for 1C. It's adding acetic acid and potassium chromate. So we are going to add 2 drops of acetic acid and add 5 drops of potassium chromate. So drops of potassium chromate, and that is your observation after adding potassium chromate, and that is for part 1C2. Okay, 1C2. Next, we are doing part D. We are adding ammonia. For part D, adding ammonia, mixing, centrifuging, we are working on part 1D and 1E. I added the ammonia. I centrifuge because it tells me to centrifuge and discard the solid part. We don't need the solid part. The liquid portion is asking me to add the nitric acid. Okay. I had the precipitate, I add the ammonia. Now I'm adding to the liquid portion. This is the part 1E1. Part 1E1, adding nitric acid. Okay. This is what happened when I added nitric acid. Make sure you record your observation And I'm done with part 1. I'm going to part 2A. Record your observation. For part 2A, first I want to make sure if there is any leftover, if there was any lead, if there is any leftover of lead. So I add the sulfuric acid, 3 drops of sulfuric acid. Because it's asking me to add 3 drops of sulfuric acid. No precipitate, because this is just for cleaning. So I don't have problem telling you. I don't have to do the centrifuge part. And I'm going to do part 2B now. Separation of bismuth, if there is any bismuth. So I add ammonia until it's basic. So I add ammonia until it's basic. So I'm adding which ammonia? 15 mole until it's basic. How do we test if it's basic? Take a red litmus paper, add drops of the solution. It's blue, so the solution is basic. Solution is basic. But to centrifuge, next step, centrifuge. Make sure it's balanced before we centrifuge. So I'm on step 2, part 2, B2. Okay. Okay. I'm supposed to separate the precipitate, but there is no precipitate. So there is no precipitate in this step. So because there is no precipitate, I'm going to skip the 2B3 and B4. Because there was no precipitate left in there. Going to skip the B3 and B4. And I'm going to move to part 2D because I didn't have precipitate. I cannot do part 2C now. Okay, so I'm going to move to part 2D. Going to add acetic acid to the blue color solution. We're going to add acetic acid until is acidic. Then we add the K4FeCN6. So to make sure it's acidic, use a blue litmus paper. Going to add enough acetic acid until is acidic. Okay. The blue litmus paper turned pink. That means the solution is acidic. To this solution, adding the reagent that is asking in step 2E1. And I get that color. You can record your observation. This is after adding the K4FeCN6. Based on the evidences you recorded for the unknown and the evidences that you had from last lab, you are going to identify your unknown based on presence and absence, which ions are present, which ions are absent from group 1 and 2, group 1 and 2 of the unknowns. There is a pre-lab questions which you should answer, and the instruction will be given to you by your professor. For my classes, students, they turn in the pre-lab questions as assignment before the class, and then they turn in the post-lab questions as assignment after they watch the video, after the scheduled time for that experiment. And we are done with the unknown procedure. You are going to find what ions are present, which ones are absent, and I'm going to stop recording for this.